Hello, it is John Leong speaking from Hong Kong. In this video, I am going to show you how to drive a small display with a touchscreen, like this one. It is an In-Cell OLED display.
There are so many applications that find the display useful. Just to name few of those, designers use it to display real-time temperature in smart kettle, in wireless earbuds to display the battery life of charger, in high-end audio equipment to display the volume control, song title, and running time of music. In smart toothbrushes, an OLED display is used to display different cleaning modes and brushing time. So, how do we start? We need to study the datasheet. Our display is a passive matrix monochrome OLED display. The resolution is 96 x 128 pixels. There are 4 In-Cell touch keys on the screen. Slide gesture detection is available. That means you can swipe the screen like a smartphone, and there are 4 capacitive keypads as external buttons. To fully understand how it works, I have designed an evaluation board as a testing platform. An off-the-shelf microcontroller kit, the L432KC is used as the host to drive the OLED. This kit costs only $12 something, and it is readily available. The OLED requires 12 volts as the operating voltage. So, I have designed a DC-DC converter to supply the voltage. A buzzer is on board as an audio feedback when we touch the screen. This is a simple evaluation board with full schematic available. You may download the PDF file from my GitHub. Let's see how it runs side by side with the toothbrush. Mimicking the icon transition animation seems good. Traditional electronic projects start with Hello World. I am doing the same here. Let's start setting up the development environment. The first thing is to download the source code from GitHub. Visit GitHub with keyword SSD7317 to search. The repository is stored in techtoys/SSD7317. There is a long README file to describe how to use the In-Cell touch display. Full description with source code and some confidential documents are all available in this repository. From the top right, click on the code button to download the complete repository in zip format. If you have installed GitHub Desktop, you may choose to clone the repository to your computer. Now you have the compressed file. Unzip it to any location you feel comfortable. In my case, I am uncompressing it to D drive. The demo projects are stored in the examples folder. Next, we need to install STM32Cube IDE. Click on the Get Software button. Go through a simple registration procedure with your name and email address. In 1 to 2 minutes, you will receive an email message with a download button. Installation is a straightforward procedure streamlined by ST. There is not much difficulty in this step. Launch the IDE from desktop. You will be asked to select a directory for the workspace that stores project preferences and configurations. You may choose to use the default location suggested, or you may create a new directory like what I am doing here. I love to use a separate workspace for STM32. So, I just create a new directory as STM32 IDE workspace at the root of D drive. Click the Browse button and select the new folder just created. Click Launch. You will see a splash screen with 4 big buttons. Click the third button to import project. Click on the directory button. Browse to the project folder of SSD 7317Z you have downloaded previously. Point to the root directory of the examples folder. It is the root directory to use because we want to import all 4 projects. Let's run the Hello World project. This project simply displays a text message on the OLED. Double-click on main.c file, you will see the full source code to run it. Before building the project, we need to configure the IDE to set up the path for the display driver. This is to let the building environment know where to find the driver's source code. Do it by right-click on the project title to expand a hidden menu, go down to the last option, Properties. Select Linked Resources. There are 2 tabs, Path Variables and Linked Resources. In the Path Variables tab, select SSD 7317Z to change its setting to point to the root of drivers folder. This is the location of the header and source code for SSD 7317. Next, expand C and C++ build drop-down menu. We need to change the build variables. Select SSD 7317Z and click Edit. Point to the root of drivers folder. You may inspect the path variables from the Paths and Symbols tab to make sure everything is correct. Finally, click Apply and close to exit. Okay, that's all for configuration. Go back to the Project Explorer. Right-click on the project title, click Build Project. There are build messages in the console. Good. There is 0 error. There are several warnings because I've left some of the functions generated by the IDE unused. That is okay. It doesn't impact how the code runs. Let's see how it looks in real hardware. Run the project by clicking the ladybug icon from the menu. Hello world. Want to use the touch screen? Sure. Close Hello World. Select the Content Scroll project. This project allows you to scroll icons by swiping. Before building it, we need to set up the built-in path variables like what we have done in Hello World. Open main.c file. Scroll down to the line 191. Locate the function spring scroll. Comment it. Uncomment the line for linear scroll. Save all. Go straight to the ladybug icon. Select any of the debug configurations. Click OK to proceed. And run. Swipe the OLED up and down, you will see the icon scroll with its title and counter updated. Single touch on the icon will invert the color with a beep. That is a simple button. Let's try another animation with spring scroll that bounces an icon like spring recoil in transition. Okay. We have created a new transition animation by manipulating the framed buffer. How the source code actually works. Let's get a deeper understanding in the next section.